A warm welcome to all. I am Priyadharshini of 3rd B.Sc Mathematics. On this occasion, I am glad to speak about the great mathematician Srinivasa Ramanujan. He was born on December 22, 1887 in Erode, Tamil Nadu. He was one of the India's greatest mathematical genius. Fellowship of the Royal Society is an award granted by the judges of the Royal Society of London. He was died on April 26, 1920 in Kumbakonam, Tamil Nadu. Some interesting facts about Srinivasa Ramanujan. The book that started it all. The one book which changes the Ramanujan's life in the field of mathematics. He had its interest in mathematics unlocked by a book. It wasn't by a famous mathematician and it wasn't full of most up-to-date work. The book was a synopsis of elementary results in pure and applied mathematics by George Shoebridge Carr. The book consists of thousands of theorems, many presented without proofs, and those with proofs only have a briefest. Early failures. Ramanujan did not suspicious start to its career. He obtained a scholarship to college in 1904, but he quickly lost it by failing in non-mathematical subjects. Another try at college in Madras also ended poorly when he failed its first arts exam. It was around this time that he began its famous notebooks. In 1910, he got an interview with R. Ramachandra Rao, the secretary of Indian Mathematical Society. Rao was at first doubtful about Ramanujan, but eventually recognized his ability and supported him financially. Go West, young man. Ramanujan rose in prominence among Indian mathematicians, but his colleagues felt that he needed to go to the West to come into contact with the forefront of mathematical research. Ramanujan started writing letters of introduction to professors at University of Cambridge. His first two letters went unanswered, but his third one of January 16, 1913 to G.H. Hardy hit its target. Ramanujan included 9 pages of mathematics. Some of these results Hardy already knew. Others were completely astonishing to him. A correspondence began between the two that culminated in Ramanujan coming to study under Hardy in 1914. Get pi fast. In his notebooks, Ramanujan wrote down 17 ways to represent 1 by pi as an infinite series. For example, Gregory Leibniz series discovered in the 17th century is pi by 4 is equal to 1 minus pi by 3 plus 1 by 5 minus 1 by 7 plus etc. This series converges extremely slowly. It takes more than 600 terms to settle down at 3.14. Let alone the rest of the numbers, Ramanujan came up with something much more elaborate that got to 1 by pi faster. 1 by pi is equal to square root of 8 divided by 9801 into open the bracket 1103 plus 0659832 divided by 24591257856 plus etc. This series get you to 3.141592. This series was used in 1985 to calculate pi to more than 17 million digits even though it hadn't yet been proven. Taxi cab numbers. There is a story behind this. One day, Hardy took a cab to visit Ramanujan. When he got there, he told Ramanujan that the cab number is 1729 was rather a dull one. Ramanujan said, "No, it is a very interesting number. It is the smallest number expressible as the sum of two cubes in two different ways. That is 1729 is equal to 1 cube plus 12 cube is equal to 9 cube plus 10 cube. This number is known called the R.D. Ramanujan number. 100 out of 100. R.D. came up with a scale of mathematical ability that went from 0 to 100. He put himself as 25. Ramanujan was 100. When he died in 1920 at the age of 32, Ramanujan left behind three notebooks and a sheaf of papers, the lost notebooks. These notebooks contain thousands of results that are still inspiring mathematical work decades later. I conclude my speech after the life story video. I thank all of you for listening to my speech on great mathematician Srinivasa Ramanujan. Thank you very much.